Okay, I'm going to do some videos just on limits from the left and the right, and then do limits one-sided, limits at infinity to show you what I'm talking about. All right, so now look at what we have. We just have, that's a polynomial, x to the first plus 2. So when we direct substitute, -2 plus 2 is 0. So that's direct substitution. If we use the limit laws, we're going to separate two limits by a plus sign. So the limit as x approaches -2x plus the limit of 2 as x approaches -2. Well, then when you substitute -2 in for that x, you just get -2, and that other 2 is already a constant. So when you add those together, you get 0. Well, that's what we got before. All right, so let's come over here. I don't know if you can quite see that, but that says x cubed minus f of the limit as x approaches 0. The function is x cubed minus x squared plus 3. And when you substitute in 0, 0 subtract 0 plus 3 is 3. When you plug that into the limit laws, remember, and I'm going to do this. I almost used, there we go. So the limit of a cube is the cube of a limit. The limit of a square is the square of a limit. I almost used logarithmic properties. So then we're going to write it as, here's the difference, here's the sum. So the limit, the whole thing is being cubed of x. So that just is going to be 0 cubed. And then this is the square of a limit. So when we plug 0 in, we have 0 squared. And then that's just the limit of 3, which is 3. Well, 0 subtract 0 plus 3 is 3. They won't all. There we go. All right, so now down here, you just need to remember that a root is the same thing as to the 1/3 power. So that's all I wrote right there. So it's saying that whole function inside is the cube root, but there's a negative sign on the outside of that. So this is what that would look like. Well, first of all, if you do direct substitution, let's do that. Direct substitution. Direct substitution, we'd put a -2 in there. Well, -2 plus 3 is -4, plus 3 is -1. Well, the cube root of -1 is -1, but there's a negative sign on the outside. So that answer is going to be 1. Now, if we do this, remember, there's a negative sign. That negative goes out in front of the limit, but then this is the cube. The limit of a cube root is the cube root of that entire limit. And inside that radical, we've got a couple things going on. We have the sum, but here we have a coefficient. And remember that the limit of a product is the product of a limit. So this is 2 times the limit of x as x approaches -2 plus the limit of 3 as x approaches -2. And all of that is to the 1/3 power. So then this just becomes, there's still a negative sign, 2 times -2 plus 3 on the outside to the 1/3 power. Well, 2 times -2 is -4. -4 plus 3 is -1. So now we've got -1 to the 1/3 power. Well, -1 to the 1/3 power is -1, and negative times negative is +1. All right, and then on this fourth one right here, always check, do direct substitution before you bother factoring. I can even look at that. Or when this factors, if it does, will there be a 3 involved? No. But when I plug 0 in, so I don't even have to do the factoring first. 0 plus 3 is 3. 0 plus 0 plus 1 is 1. So that height is 3. All right, I'm going to pause it. Okay, we've got 4 others to look at in here, just so I'm going to do this. So we're not even looking at that right now. So for this one right here, it's a trig function. So what it says is as x approaches 1/2. So you just plug into your calculator. What is the cosine? So remember this right here, right? The cosine graph looks like this. Well, right there at pi halves, that's 0. Well, what's the opposite of 0? 0. So the work that you would do is just that, just like that. You could also look at the unit circle. Whoops. Look at the unit circle and remember at pi halves, that's up there at 90 degrees, and that coordinate point, that just occurred to me, I think I undid a bunch of stuff, is 0, 1. Well, remember the x values, so cosine at pi halves is 0, the opposite, there we go. Let me see if, I hope I didn't ruin a bunch of stuff. Okay, so then we're going to go on to this piecewise right here. Oh yeah, I didn't ruin anything good. Okay, so notice this is saying we're going to find the limit as x approaches 3, but it's piecewise. It's not from the left or right. So what you're going to do is you're going to plug 3 when it's not from the left or the right. So this inequality doesn't help you. If it was from the left, you just use this one. If it's from the right, but since it's the both left and right, plug 3 into there. Well, the opposite of 3, negative 3 plus 3 is 0. And then plug 3 into this. 2 times 3 is 6. 6 subtract 3. When these are not the same height, that means the limit does not exist. So, and because this is broken into 2 pieces, it's not one-sided, you just rewrite limit of f of x as x approaches 3 does not exist. It does not exist because those 2 heights are not the same. All right, let me get this one out of the way. Now we've got one of those absolute values, and look, it is not one-sided. So you have to look as you're coming from the left and as you're coming from the right. But notice right here, these both have a 4 in common. So you'll factor the 4 out, and then the x minus 2 would go in parentheses, and then that would match. Well, remember what I said, whatever zeroes out the denominator, is that's where the graph will be shifted. So we're here at 2, because the opposite of negative 2 is 2. And then this slope, don't think about a slope that way. Think about it as, oh, that's how far from the x-axis, that's how far you go up and how far you go down. And where that invisible asymptote is, where x is equal to 2, you put the hollow dots. And since this is positive above the x-axis, the graph will be a horizontal line headed in the positive direction and below the x-axis. But look at, as you're looking from both the left and the right, this red height does not agree with that green height. So the answer is does not exist. Now, if it were one-sided, you could say, oh, from the right side we're at a height of 4, or if it was a left-sided limit, you'd say, oh, we're at a height of negative 4, but it's neither. It's from the left and the right, those heights don't agree, so it does not exist. And finally, we have another rational graph. This is not one-sided. So when you plug in negative 2 and you get a 0 down here, you know you can't, it won't work. So you go ahead and factor. So factors of negative 8 that add up to negative 2 are negative 4 and positive 2. Well, then this x plus 2 factor and this x plus 2 factor, leaving the x subtract 4. So then you rewrite it as the limit as x approaches negative 2, the function x subtract 4, and then you put just direct substitution. Negative 2 subtract 4 is negative 6. Okay, so for number 9, pay really, really close attention to what I'm going to say. Notice this is a piecewise. It is not one-sided. So, but look at what this says. Not equal and equal. So normally you'd think, okay, that's going to be discontinuity, but we don't care about discontinuity. This is not a one-sided. We're not asking about discontinuity. What we're doing is we know that this one right here, there's going to be a hole in it. Well, look it. If there's a hole in that graph, from the left and from the right, they're going to be headed towards that same place. So when you have a limit, as x approaches a c, and it is a piecewise, and one says not equal and one says equal, this is the function that you choose to show your work. So this is what I mean. We're going to take this function, negative x plus 1, and we're going to write the limit as x approaches 1, negative x plus 1, and then we plug that 1 in here. Well, the opposite of 1 is negative 1. Negative 1 plus 1 is 0. So how you know that it is this is because this is the one where the function is actually going to continue on either side of that hollow dot. This function is just going to be one solid dot. There is no function on the left and the right. So the one that says not equal, that's the one that you use. You plug into here. Remember, this is when it is not piecewise, when it is not one-sided. When you just see that x is equal to 1, you choose the not equal one, you plug that function, and then use direct substitution. Okay, now I'm going to get rid of that stuff. Oops, not me. So then you've got these ridiculous limits of these compound fractions. So remember what I said, if any item is by itself in the numerator and denominator, automatically write that over 1. Okay, and then notice here's a fraction and here's a fraction. Those are different denominators, so you would multiply this numerator and denominator by 3, this numerator and denominator by the 3 plus x, which is what I did right there. And then notice, these two now are going to share the same denominator. 3 times 3 plus x, and then up there, 3 times 1 is 3, and then we're going to subtract this whole thing, which is what I did right there. I did 3 times 1, and then put a subtract sign, and then in parentheses, 1 times 3 is 3, 1 times x is x, but you're subtracting both of those things. So 3 subtract 3 is 0, and then you have 0, but there's this negative, so it's 0 subtract x, which is negative x. And I'm going to leave this just like this for now. But now I have a fraction over a fraction, so I'm going to multiply the numerator and denominator by the denominator fraction. So those cancel. And then look at this negative 1x, the x and the x cancel, and now we have negative 1 times 1. And down below, now we can do the distributive. So 3 times 3 is 9. That's not good. Plus 3 times x is 3x. When you plug a 0 in there, you get negative 1/9, not negative 1/6. Okay, and now we have a rational, meaning it's a fraction, right? But as part of the fraction, either the numerator or the denominator has a radical. So it's rational because it's a fraction, and then in either the numerator or the denominator, there will be a radical. All right, and then remember, this is where you multiply by the conjugate of the radical term. So the conjugate of radical x plus 6 subtract 3 is radical x plus 6 plus 3. All right? So then when you multiply that, well, remember what I said, just leave this exactly as it is. And then down here, you're going to multiply the first times the first, and that just removes the radical sign, and then negative 3 times positive 3, which is negative 9. So I left the top part exactly as it is, and then this radical times this radical, the x plus 6 comes out, and then negative 3 times positive 3 is negative 9, and then when I simplify, 6 subtract 9 is negative 3. And then look at what happens. The x minus 3, the x minus 3 can cancel. Then you can use direct substitution. 3 plus 6 is 9. The square root of 9 is 3. 3 plus 3 is 6. Okay, and finally, for right and left side limits, you've got these special limits down below. For now you memorize, but later on when you know L'Hopital's rule, this will make sense and you won't have to have this memorized, but for now you do, that these are special limits, and oops, I left this off right here, is equal to 1, all right? So then so for this one right here, notice the denominator has to match the theta. Remember, with trig, whatever's inside the parentheses, it's called the argument. That's called the theta. The denominator has to match the theta. In order to do that, we would have to multiply this by a fraction of 3/4, so the fourths would cancel. But because we're multiplying the denominator by 3/4, we multiply the numerator by 3/4, but remember the constant rule, it comes out in front. So then you write 3/4 times the limit as x approaches 0, 1 subtract cosine 3x over 3x. Now that these match, we know that this whole phrase right here, this entire phrase equals 0. So now it's just 3/4 times 0, which is 0. Okay, I'm going to cover that up. And now we've got the sine one. We need the theta, the denominator, to match the theta. So we're going to multiply numerator and denominator by 4/5 and bring that constant out in front. So now you've got 4/5 times the limit as x approaches 0. Sine of that theta over that same argument as a function. And remember, this entire function is equal to 1. So now we can substitute, oops, I did not mean to put we can substitute that whole thing in for 1. And so 4/5 times 1 is 4/5. Okay, so I hope this video helped how you simplify videos as x approaches c from the left and the right. I hope this helped.